All right, here are the solutions to the rate story from 2014. Let's read it together and see how we're going to solve it. So hopefully you try your best first. But if you need support, here I am. Grass clippings are placed in a bin and where they decompose. So from 0 to 30, the amount of grass clippings remaining is this equation. So I know I'm going to type that into decimals. Where A at T is measured in pounds and T in days. So that's a rate that I'm given, pounds and days. That's the amount in the bin in terms of measure, the rate. How much grass is being put in that bin in pounds per days. Find the average rate of change. That's a rock. That's different than average value from 0 to 30. So let's start there. Hopefully that's simple. So for the average rate of change from 0 to 30, that's A at 30 minus A at 0. That's Y2 minus Y1 over 30 take away 0. And then you'd put that in the calculator and get your answer and put in units. So let's put that equation in our calculator right now. So A at T equals, that rate equation, 6.687.931 to the exponent T. Is that right? Double checking. I'm going to do this, a fraction, and A at 30 minus A at 0, and then 30 take away 0, or 30, and that gives me negative 0.196, just truncate, and then I need units. So the average rate of change is still a rate, average rate of change, and that's in pounds per day. So that's the average rate of change over the 30 days. That was it. I don't have to explain anything else. Make sure you put units of measure in it, which I did. So 1A is done. 1B. We're trying to do these questions in 15 minutes or less. Find the value of the derivative of 15. I can do that easy enough. Go back to here. Type in the derivative, A derivative at 15. And then write that answer down, negative 0.163. Now be careful here. This is a derivative of a derivative. So A is already a derivative. So when you take the derivative of a derivative, the unit's going to be pounds per day per day. Then it's probably going to say, explain what you just did. So interpret the meaning. So we start with 15. At what? At day 15. What's happening? The rate of grass clippings is increasing at a rate of, it's a rate of a rate, at a rate of, no, sorry, not increasing, negative number, is decreasing at that rate. So the rate of grass clippings is decreasing at a rate of a rate, 0.163 pounds per day, or day squared. Not that one. So 0.163 pounds per day, or day squared. Done. C. Find the time for which the amount of grass, so I would have to integrate the rate, is equal to the average amount of grass. So this is average value, and turn it. So find the time for which the amount of grass is equal to so first of all, the average amount would be integrating from 0 to 30. And then I would, so this is the average value, and divide by 30 is equal to the amount. So we're going to make these equal to each other and figure out what time is that amount equal to the rate. All right, let's type that in. Now, we already have the average here, which is, so I'm going to go y equals that number, negative 0.1968. And then I'm going to zoom in and think, at what time are they equal to each other? Think this through, because that's way down there. So here I have this. So the amount of clippings would be to integrate. Let's see if we can do this. And so from 0 to t, this is going to give me the amount of clippings. So the average amount of clippings rate is negative 0.196. So I want to know when that's equal to that number. Right here. No, that's the average rate of change. That's what I was doing wrong. Let's try this again. So we actually haven't put in the average value yet. That's what I was doing wrong. So let's do that first. How do I find average value? So divide, we're going to integrate. And we're going to integrate from 0 to 30. And then in the denominator, 30 take away 0. And I get the answer 2.7252. So that's what I'm going to go y equals, that number, 2.752. So I want to know when they equal each other. And at what time would they be equal to each other? So that answer there is at 12.418 days. That means the average value is equal to the amount there on that day. All right, next step. Part D. Let me move to here. So in part D, it says, when t is greater than 30, do a linear approximation, which means do a tangent line. At t equals 30 is a better model for the amount of grass clippings being used to predict the time. And then predicts the time at which there will be 0.5 pound of grass clips remaining in the bin. So we need to do a linear approximation, a tangent line. So in this case, we would normally write down x, y in the slope. But instead of x, they use t, so we're going to use t. And in this question, t, it says, is equal to 30. To find what y equals, we're going to plug 30 in and go a at 30. That's going to give me my slope. So I'm going to move over here. So a is the derivative. So a at 30 is 5.396. Oh, that's not 30. Why not 30? There it is, 0.783. Then m is the derivative. So I need to do the derivative at 30 for the slope. Do it again. There it is. Which is negative 0.055 or 56. And now I have the values that I need. So recognize this is just a at 30, and this is the derivative at 30. So I'm finding a linear approximation of the derivative. So I'm just following the steps. The x value, the y value, just plug in 30, and then the derivative of that is the slope, and that means the equation would look like this. Y equals the slope. Now we have t, so I'm going to go t subtract 30, and then the y value, which is positive 0.783. In the question it says, when will that be equal to 1/2 or 0.5? And then I would solve that. So if you want an easy way to solve that, we're going to come back over here. We don't need those graphs anymore, so I'm going to click on the color to not have a graph, and then I'm going to type both those equations in. So I'm going to type in left side and right side. So I'm going to type in y equals negative 0.055 t subtract 30 plus 0.783, and I'm going to type in y equals 0.5. And I want to know where the two, it will be after 30 where they meet, which they do. So where do they intersect is the solution to that. So that's when t equals 35.145. Then I'm going to write a sentence for that. So the question is, predict the time where they'll be. So at t equals 35.15 days, there will be 0.5 pound of grass in the bin. Done. Again, if you need to, at the end after you do your homework, to go back and do the question over again to feel better about it, it's okay to do it twice or 3 times, kind of like practicing piano. You can't just play the song once. It's probably good when you practice something that you do it 2, 3, 4 times so you feel better about it. All right, next question. And again, I'm right there under 15 minutes, so yay. All right, this one is from 2013. So let's read this together again. On a certain workday, the rate, so again this is a rate story, at which unprocessed or processed gravel arrives at a gravel processing plant, given by this equation. I know I'm going to type that into Desmos. And T is measured from 0 to 8. At the beginning of the workday, the plant has, this is going to be important, 500 tons of gravel to begin with before they've done anything. During the hours of operation from 0 to 8, plant processes gravel at a constant rate of 100 tons per hour. So we actually have 2 rates here. One rate is gravel arriving that is not processed, and then how long does it take to process or process the gravel? It's a constant rate of 100 tons per hour. So I'm going to look at part A, and just as I need it, I'm going to go to Desmos and answer it. So first, nice and simple, what's the derivative at 5? So I'm going to type this equation as G. So I'm going to get rid of these things. I'm going to double check to make sure I type it in correctly. So we're going to go G at T equals 90 plus 45 cosine. Because it's trigonometry, it's periodic, I'm going to put a restriction on it, or else it'll look kind of silly in a moment. Make sure I have it correct. So 90 plus 45 cosine that. So if I look at the graph, see how it kind of looks like, whoa, what's happening here? So I'm going to put a restriction on it right away from 0 to 8 because it says that. And then I don't have to look at that. So then when I look at it, I have a much, like, it's just this part, right? From 0 to 8. Much easier to look at and understand. Okay. And then it said find the derivative at 5. So G derivative at 5. And so I have my answer, negative 24.5 2.587. And then, let me see if it says explain what that means and the unit. So we know the derivative of a derivative, right? So this is a rate, so the rate of a rate. So this rate is measured in hours and hours, so tons per hour. So this is going to be tons per hour, or tons per hour squared. And this is interpret. So we did the correct units. Interpret what that means. So start with 5. So what does that mean? At what time? So from 0 to 8. So I'm going to say at hour 5, the rate of unprocessed gravel arriving is decreasing at a rate of, so it's a rate of a rate, that's why we have this per hour, negative 24.587 tons per hour, or hour squared. All right, part B. In part B, find the total amount. What does that mean if you're trying to find how many? So we know we're going to integrate. So find the total amount of unprocessed gravel that arrives at the plant during the hours of operation on this working day. So just the amount of gravel that's arriving. So that's from 0 to 8. So when we integrate the rate, it'll tell me how many. So I'm going to come back here. And I'm going to go to calculus and integrate from 0 to 8. And that's 825.551. Now when you integrate a rate, it's just the unit, which is in tons. And then I double check to make sure, do I need to explain anything? So I integrated, that's how many tons of gravel. Find the total amount. It doesn't say to explain your reasoning or justify your answer. We're good to go. Part C. Oops, sorry. There we go. Part C. Is the amount of unprocessed gravel at the plant increasing or decreasing at t equals 5? And then show the work that leads to your answer. So the amount, is the amount increasing or decreasing? That's the derivative again. So G at T is the rate of it arriving, and then what's the rate of it leaving? I'm going to call that P. When it's processed, that rate is just 100, a constant 100. So to understand if it's increasing or decreasing at 5, we just plug in 5 into the rate and subtract and say, okay, this is arriving and this is leaving. So is the amount increasing or decreasing? Oh, and this answer is always 100. So whether it's at 5 or 1 or 2, 3, 4, 5, 6, 7, 8, the answer is just 100. So it's just G at 5, subtract 100. So let's see what that answer is. So that's negative 1.859. And then show the work that leads to your answer. So the answer is it is decreasing. So at hour 5, the amount of unprocessed gravel, processed? I don't know how to say that. Unprocessed gravel is decreasing at a rate of negative 1.859 tons per hour. All right, last one, part D. Press pause if you need to. I don't want you to race through it, and if you need to do this in chunks and come back, it's okay. what is the maximum amount of unprocessed gravel? Maximum amount is a table of values question during the hours of operation. So this is going to be the longer step of all of them. So I'm going to do a table of values. T, so the two ends, which are 0 and 8. And then how do I know how much gravel is there? Is I integrate the rate. So we have rate going in and rate leaving. I integrate that, subtracting from 0 to whatever number I want. So first of all, if I go 0 to 0, and I have to remember the thing I circled at the beginning? How much do we have to begin with? So the amount of unprocessed gravel, we started with 500. So when I plug in 0, I was tempted to say 0, but in the question it says we actually start with 500. Then I'm going to do the same with 8. So I'm going to go to my Desmos, and I'm just going to plug in 8. So that means I'm going to integrate from 0 to 8. And it'll give me the answer, which is 25.551. That's how much gravel there is at that time. Now we still have to do what? So think of this as an equation where we integrate this. In fact, I would use x, because what am I going to do next? And then plus 500 here is I'm going to take the derivative and make it equal to 0. So when I take the derivative here and plug in, I do get g at t minus 100, but the derivative of 500 is 0 because it's outside of the integration. And then I make it equal to 0. Add 100, and I need to know when this is equal to 100, that's going to be my critical value. So I'm going to go back here, and I want to know, I already have g at t there, so all I have to type in the second box is just y equals 100 and see where they cross. So type in y equals 100, and you can see that it crosses. They both connect, even though they both are green. I don't like that. How do I change the color? I don't know how to change color. Oh well. So the number is 4.923. That's a critical number. So I'm going to put that in, 4.923. Then I'm going to plug that into here to see how much how much gravel there is at that time. So back to the screen again. Now I'm not going to retype it in. I'm going to change this 8 up here. I'm going to change it to 4.923. And it's 135.376. Then I'm going to read the question again carefully to make sure I answer it correctly. So what is the maximum amount? So I am looking for the y coordinate, not the time it happens, and then during the operation. So at hour, t equals 4.923. A maximum amount of 135.376 tons of unprocessed gravel remains. And that's it. You did it. Mr. G Math over and out. Till next time, again, I encourage you, do the question over again, like practicing piano. Not just once to play piano, but maybe you need to do it 2 or 3 times so that you really understand it. Maybe you have a good question for me too, because I'd like to answer it. Till next time.